Now we want to look at Marlowe Run. Marlowe Run is a tool running in the browser that will allow participants to a Marlowe contract to execute that contract. As was mentioned in the first lecture, at the moment Marlowe Run is not yet completed. So at the moment there are only 3 hard-coded example contracts that you can play with. But they are connected to the private testnet. So it's not just a simulation. Transactions are actually submitted to this private testnet. Each participant to a Marlowe contract would have his own instance of Marlowe Run running, and then Marlowe Run will prompt the user to perform certain actions when it's the user's turn. So that may be a deposit into a contract, or it may be a decision, a choice to make. One of the 3 example contracts uses 3 participants, and that's the one I want to demo. So normally, these 3 participants could be at different places in the world, and each would sit at his own computer and run his instance of Marlowe Run. But of course, now, in order to demonstrate, I will run 3 separate Marlowe Run instances on my own machine. And Marlowe Run is linked to a wallet, to a Daedalus wallet. So I want one instance for each of the 3 Daedalus wallets I created. Normally, out of Marlowe Run, you could generate a new wallet, but I don't want to do that because I already have my wallets, so I will use the second option to restore a wallet. And I can give it a name. I'll choose the same names that I also used in Daedalus, Marlowe 1, Marlowe 2, Marlowe 3. I get a warning here that that already exists, and that is because I played with this earlier. So I already created these wallets before. But let's do it again. So now I have to enter the recovery phrase for this wallet. And I told you earlier that I saved the 3 recovery phrases into a text file. So I'll paste them now and click Restore Wallet. Now here we see our wallet. At the moment, the balance shows 0, even though there should be funds in this wallet, but that's because the wallet is still synchronizing. So we need a little bit of patience until it's fully synchronized, and then our funds should show up. And there they are. So now let me create the second and the third instance of Marlowe Run. So you can find this URL for Marlowe Run on Canvas. Now, when I do it like that, I'm still connected to the Marlowe 1 wallet, but I want to connect this instance to Marlowe 2. So what I do is I drop the wallet, and then I get back to this initial screen. So again, restore wallet. Now give it a different name, say Marlowe 2. Paste the recovery phrase. And check whether I see the funds. So again, it needs to synchronize. And there are my funds. And let's do it one more time for the third instance connected to my Marlowe 3 wallet. So again, have to drop this wallet, restore Marlowe 3, paste the recovery phrase, click restore, and wait until it's synced. And there are my funds. So let's check again. 1, 2, and 3. Now that we have our 3 instances of Marlowe Run connected to 3 different wallets, let's interact with the contract. So I click choose a template, and there, as mentioned before, are 3 example contracts. And I think the most interesting one is this CFD, contract for differences. So the idea here is that there are 3 participants, 3 roles, 3 parties to the contract. One is called party, one is called counterparty, one is called oracle. So the idea is first party deposits some ADA in the contract, then counterparty deposits some ADA in the contract, and then the oracle declares the price of some asset. Can be anything. for example, a bar of gold or whatever. Then there's a waiting period, and then the oracle again declares the price of the same asset, which can have changed in the meantime. And then if the price has increased, the counterparty gets the difference in price. And if the price has decreased, the party gets the difference in price. So let's try this. Click on Setup. First, we must give it a name. Let's call it CFD. Second, we must say who is supposed to assume which role. So as I said, we have party, counterparty, and oracle. So let's say our Marlowe 1 instance is party, our Marlowe 2 instance is counterparty, and our Marlowe 3 instance, which is the one I'm using right now, is the oracle. Then there are various deadlines that I think I can't edit, so they are hard-coded. So it's always in steps of 5 minutes. So in the first 5 minutes, party must deposit the ADA. Then in the next 5 minutes, counterparty must deposit the ADA. The next 5 minutes, nothing happens. Then in the next 5 minutes, the oracle declares the first price. Then for another 5 minutes, nothing happens. And finally, the oracle declares the next price. And then depending on how the price changed, whether it increased, whether it decreased, and by how much, either the party or the counterparty get the difference. We can click review. So we see all the parameters again here. Oh, and I forgot, I must set 2 parameters I can actually set, namely how much party and counterparty should deposit. So let's say, just to try it out, both deposit 1000 ADA. I could choose different values here, but let's go with that. Okay, and I see that in order to start the contract, I need to pay 8.2 ADA. And this seems to be relatively high, and this is caused by the so-called min UTXO requirement on Cardano. So on Cardano, we have these UTXOs, the unspent transaction outputs, basically coins. And each of those coins must contain at least something like 2 ADA. It's not exactly 2 ADA, it also depends a bit on the size of the UTXO, but roughly 2 ADA. And the idea is to prevent attacks where an attacker could create thousands or tens of thousands of UTXOs to put a strain on the memory of the nodes and slow down the blockchain. So in order to make this kind of attack prohibitively expensive, there's this rule that each UTXO must contain roughly 2 ADA, which means that probably this transaction will create 4 UTXOs. So why 4? So 1 will be for the contract itself, it will encode the state of the contract. And then the 3 others are for so-called role tokens. So the idea is that on Marlowe, in Marlowe contracts, we have these participants, the parties, and each party can be represented by an NFT, which is minted for this purpose. And the point of using NFT and not just using an address, like a wallet address, is that with this NFT, you can pass that on. So you can give your NFT, your role token NFT to somebody else, and then that somebody else can assume that role. So right now I'm the Oracle, but I could take my Oracle role token and send it to somebody else, and then the receiver of the token from that point in time on could act in my stead as the oracle. So let's do this. So now the transaction was submitted to start the contract, and we see we were lucky. So we only had to wait a couple of seconds until the transaction was included in the blockchain. So in general, this on average will take 20 seconds because on average there's a block every 20 seconds on the Cardano blockchain. But this is a stochastic process, so it can vary. It can be much shorter, it can also be much longer. So now that the contract has been initialized, we see now there's current step 1. Party has to make a deposit of 1000 ADA. We are in Marlowe Run instance 3, so we are the Oracle party, not the party. That, if you recall, was associated with Marlowe Run instance 1. So let's switch to that. And we see that the contract has been picked up. So Marlowe Run has detected that the contract has been started on the blockchain where Marlowe 1 is a participant. And we see that here this button is active because now we are in the instance for the party and can therefore do this deposit. So let's do this. So we see we're paying 1000 ADA from our wallet to the contract, and these Marlowe contracts have the concept of internal accounts. So you send it to the contract, but there are these virtual internal accounts. So we would send it to our own internal account in the contract. So let's confirm. And again, we have to wait on average 20 seconds. Okay, this was successfully included on the blockchain, and the contract progressed to step 2, where now counterparty is supposed to make the deposit of, again, 1000 ADA. So let's switch to the second instance of Marlowe Run, corresponds to counterparty, and do the deposit, confirm. And this time we had to wait a bit longer, but there it is. So now this deposit has also been sent to the contract. Now we see we are in step 3, and that is a wait. So there's no party that can do anything now because we have to wait for this time, 11 minutes now, until the Oracle can declare the first price. Recall there in the contract there were these deadlines. So it was 5, 10, 15. So we are now in this 15-minute deadline, 15 minutes from the start of the contract. So we were fast with the deposits. So therefore now we have to wait quite long until these 15 minutes are reached. In the meantime, we can see here that we get more detailed information about the contract. So we see the steps were completed. We also see the internal balances. So this step 1, we see before and after the step. Here, no change. But party before had 0 and afterwards 1000 because party made the deposit. Here, accordingly, we see that now counterparty also goes from 0 to 1000 in the internal repository, in the internal account. Here, on the other hand, nothing will change because it doesn't involve a payment. It's just a wait. Let's go back to the dashboard. So while we're waiting, we can have a look at our wallets to prove to ourselves that this is not just some simulation in the browser, but actually has an effect on the blockchain. You see here, Marlowe One wallet, the one linked to the party, sent 1000 ADA. So that was this deposit. If we switch to Marlowe 2, which is linked to the counterparty party, we see something similar. Also the deposit of 1000 ADA. In Marlowe 3, we see this payment. So that was to set up the contract. As I explained before, to create these UTXOs, one for the contract itself, one for the role tokens. Incidentally, you can see the role token here. Actually, you see many. That's because I played with this quite a lot. So one of those is our current Oracle role token. If we go to the other wallets, we should see, so 2 has a counterparty role token and 1 has a party role token. So we see that these were real transactions on the blockchain that we triggered in Marlowe Run. Okay, so the waiting period is over. Actually, I already let 2.5 minutes of the next step pass, which is the step where the Oracle can declare the first value. So I'm now in Marlowe Run instance 2. Let's switch to the Oracle, Marlowe Run instance 3, where I can actually do this. So now I have to specify the current price of the asset, whatever that asset may be. Here it says in ADA, but I do believe that that is a typo. It should be loveless, I think. So if I want to say just an arbitrary number, let's say 500 ADA. So I should probably add 6 zeros to that. 1, 2, 3, 4, 5, 6. And do this. Confirm. Now the contract update has been applied, and we have to wait again for a bit more than 5 minutes until the Oracle can give the second price. And then depending on whether that is higher or lower than the first one, either counterparty or party will get the difference out of the deposits both made. We can check the details here again. So now we see step 3. So it has been recorded here, our choice. So that choice has been recorded on the blockchain. So this is now recorded in the current datum of the UTXO representing our contract instance. So now that waiting period is also over, and we can set the second price. So recall, if the price increases, the counterparty gets the difference. If it decreases, party gets the difference. So let's say it decreases to 400 ADA. In that case, the difference is 100 ADA. So out of the 2000 deposited, 1000 by party, 1000 by counterparty. In this case, party should receive back 1100 and counterparty only 900. So I submitted this. And because there's no step left after this one, the contract should actually now be closed after this is included in the blockchain. Okay, so the contract is closed. It seems to have worked. We can, for example, check here. So there's the last step, contract closed. And if we look at the balances, they are all back to 0. Here we see that payments have been made. So first, internally, on internal accounts, counterparty sent 100 ADA, which is the difference in price, to the internal account of party. Then there is some like small stuff that's probably some minimal UTXO deposit. And then we see that from the internal account of counterparty, 900 are sent back to counterparty's wallet, and from the internal account of party, 1100 are sent to party's wallet. So as expected. So we have seen a complete run through a Marlowe contract in Marlowe Run. Next, we will look at the Marlowe Playground, and there we will look at the same contract.